don't know.
You're gonna. There you go. We're good.
Okay, go ahead and agree to recording. I don't know where it's going to be saved, but probably on mine. So.
Yeah.
Yeah.
Okay, go on. I'm sorry to interrupt you.
No, you're good. So yeah, then like what you would basically do is, because if it's just like the tentacle tube could be hooked up at the bottom, right? So that way it's just like, oh, it just drops, and it goes straight into the car. Because we could say that like, since this car is already bigger than other cars, because it has to be able to go over cars, right? So, since we already know it's bigger than other cars, and then that means we should just be able to drop packages right next to the window and just make it, again, curve down basically. So you would just have that little tentacle tube and it would just shoot down, and it would drop a distance and curve into the window, and that's no problem. That's super easy to do, right? It's just, again, that arm connected to a free end and then the fixed end. So yeah, but then we got to think about the hydraulics, right? Like we would say, like, when it wants to deliver, it would, because it would roll like a little, like, think about like a tiny little, like, those trailer, or not, yeah, like, not those, yeah, those trailers that are like the pop-ups.
Yeah.
It would be like it would be like super low, like one of those essentially, right?
Uh-huh.
And then it would go up and down on its hydraulic frame. Would you just do a scissor? Would you have it be like a scissor style? Like, how would you actuate up? Because the thing is, like, hydraulics are heavy. And
yeah, it is, huh? Are hydraulics spring?
No, they're
pressurized.
They use either like a viscous fluid to like push the item up.
Oh, hydraulic.
Yeah, so
that makes
sense.
They
use a pump and a hydraulic fluid.
What about springs? Could we use some sort of spring energy to make it easier? Or?
You could, but the thing is, really, like, springs, when they are, like, you would have to. The thing is, like, springs won't just give you free energy. Like, you can't at will, like, propulse them. You have to input a force. Like, if you want, like, let's say in this case your Y desired is height, then and your plant is the hydraulic system or whatever your lift actuation mechanism is. So like, let's say it's a spring, right? Well, the only way you're going higher is if you exert a force that stretches the spring, but then, like, the spring is going to be pulling back on you, so it's going to slow you down until you can't pull anymore, and then you're going to hit a settling height. But you have to input a force, so the spring didn't do anything but do work against you. You see? That's if it's a compression spring, or because then you're pulling it in tension or something like that. So
I see. So let me ask you, do you think that problem, the hydraulics or the legs on this auto device, will be too much of a problem for this to be a feasible idea?
Yeah, so my thing is, like, hydraulics are just super expensive. That's why you don't really, and then, because, like, the thing is, like, hydraulics leak. Hydraulics need precision fittings. Hydraulics
they do leak. Yeah.
Hydraulics are a pain in the ass. That's why no one's using them, as they're using people are using them as little as possible, except for like really high pressure or high force situations where, like, DC motors or like any electrical systems can fail potentially.
I had no idea.
What about lead screws?
Okay, so yeah, I saw a 3DOF one with a lead screw, but the problem with the lead screw is a lead screw's travel distance is you would need like multiple lead screws. So you need like staged lead screws. So you'd need like a lead screw connected to a lead screw connected to a lead screw. So it'd like actuate the lead screws and then more and then more. And like, because I did see one, I saw a YouTube video that was a guy that did a 3DOF system with lead screws. But the thing is, the lead screws are long already. So like, if you had this thing stored in the car and you need to go potentially 6 feet, like, shit, that's a lot of lead screws.
Yeah, that is pretty long.
Yeah.
That's my only thing. And then you need power transmission for that lead screw, and we all know that lead screws don't like to back drive.
Oh.
Unless you have
put in
Yeah,
an
lead screws.
inverted screw train for that.
Yeah, lead screws don't like to back drive unless you'll have like a multiple cut threads. Because if you have like most lead screws, you only have a one thread cut pass. But if you do like multiple thread cut passes at different phase angles, like starting angles, you can back drive them easier. But then like it's weird shit. My design professor Maksudi like brought in some weird back driving fucking lead screw that was like on some. He would always bring in like next level little aerospace trinkets, and we were all like, "What is this?" And he's like, "Oh, that's this, that, or the other." And we were like, "Ooh," like he would always do that shit, constant flexing,
Oh, I know what you mean. Like, I'm gonna show you how much you guys don't fucking know. Like, he's just going into class and saying stuff.
Yeah. So, but he's a super nice guy. I'm not even.
What teacher was that? Who?
Maksudi.
Oh, Masudi. I have him for
Yeah.
heat transfer right now.
No. It's like
No.
Meg Zudi. It's like a different.
Oh.
Yeah, different. Yeah, his name is Bejan.
Oh,
like
never mind.
He's a younger guy.
I see. I don't know who that is.
Yeah, he doesn't.
I
he only
never had
teaches,
him,
like-
but my roommate had him.
Yeah, he
and
only
he
teaches
always
like
talked
night
about it.
courses. Wait, who's your roommate?
Well, like, I'm not with him anymore, but I don't know if he probably took the same intro to design class in the same term. But his name was like Miguel Maldonado.
Ooh, I feel like I do remember Miguel, but I don't know.
It's pretty hard, yeah. But like, I only know that professor just because he talked about him.
Yeah. Okay. So yeah, the lead screw idea, I just don't like. I just think it's like a really heavy idea, and then like back driving. Because my thing too is like, I like the driving on top idea because then you never have the issue of, oh shit, like I need to bring this package back in really quick.
Yeah.
'Cause what if there's a bird flying?
Yeah.
Sure, the tentacle tube might save you, but shit, it might not.
Yeah, and just going laterally, like from one lane to another, sounds real sketchy, man.
Yeah. So the reason why I was really leaning towards that continuum motor is because if you think about it, it'll have it. The feedback is like the motors have feedback force. Like they have like force feedback if you have the right controllers.
Yeah.
So if the cars are moving towards each other, it can sense that, and basically the motors will compensate. So that way it's like extra flexible. And then also like speed variations, it could account for that because it has the perfect desire to move in a sinusoidal fashion, which is perfect for discrete response because because everything moves sinusoidally. So like the fact that it moves, its natural movement looks sinusoidal means that it should be pretty easy to control.
No, you're right. It would be perfect because it would just be finding the tiny bit of error, and then it would be a sinusoidal wave getting like a smaller and smaller until they're in sync.
Exactly.
It would be perfect.
There's a 6-minute video here on continuum motors that looks pretty dope on the up next, where you see that he has like a fuckload of them.
This thing?
Yeah, holy shit! It's these flexible soft robotics. Look at this shit. He's like making a Yamamoto Laboratory 2018. This shit's sick as fuck. Look at this. It's pretty cool.
Look at it.
It doesn't even look like that hard to make. Whoa,
Wow.
and his is like not even that good. It's like doing some weird spinny shit.
Yeah, mine's longer.
Okay, there we go. Wow, he like really constrained it then. Oh no, he still only has 4.
Only 4. But yeah.
So it could be something cool because like look how compact this looks. I mean, obviously like ours would have to be bigger. So, but like
What if we contact this guy?
We could.
In an ideal
is just-
world, I mean.
Wait, to get this straight, you linked this continuum robot, right, Daniel?
I linked.
Your fundamental
linked-
idea was, just elaborate. I want to hear.
Well, my fundamental idea was because you know how they have these like pointing vertical and they're just kind of like looking at the natural response.
Yeah.
My thing is like shit. If you had one of these things horizontally and you compressed it, because ours wouldn't be linked like that. because that means you can't like compress it. You know what I
Yeah,
mean?
I get what you mean. Yeah.
If it's the more flexible it is, like to compress it, that means you can get some stored energy out of it to potentially like launch it a bit.
Another problem is that like our tube needs to be hollow.
Yeah.
Okay. When you say our tube, because this thing would move, like the package would move at the front of it, and this video we're watching,
Oh,
yeah, the package would be basically at the end of it. So, like you would basically just compress it, or you would like, you could even have it basically like snake up into a convoluted shape for storage. Like you could have it do a lot of things because
that's
of
quite
how
an idea. Okay.
because how it moves pathwise. Like, you know, you could literally it would literally just slither out of the window more or less.
I see. So it would
Ooh,
kind of
could we call this thing the package snake?
let's call it snake for short. Okay, so the snake is basically the idea of like on auto. He
Yeah.
kind of he comes out of somewhere and he's one of these continuum robots that you're showing.
Exactly.
And
With
like
the package
the package is in here.
Exactly.
And then maybe it goes into the car window and then just kind of opens up and drops it in.
Yeah, pretty much. So I just don't know how we would get high above the car. Like, so that's the thing. We might have to be next to the car, even though I wish we could just be above the car because it does make life easier and cooler. But like from a like controls perspective, I already feel like maybe controlling the tentacle tube or the snake would be its own set of challenges for probably the semester.
Yeah.
And then because the thing is, like, if you say, oh, now I gotta, you know, go up above a car of a certain height, like it might not actually be that hard of a command, but it's just another variable to control. And it's
You're
like,
right.
do we really want that? Probably not.
No, let me butt in. What could we make it a constant height up above like the rest of the cars?
Shit, why not? Why not? Because we don't have a passenger compartment. We could just say like, oh, you know, like we could have it. Holy shit! What if we had like a driving tunnel?
A driving tunnel?
So it's exactly what you think it is. It's exactly what you think it is. You drive through the tunnel, and you have a spring actuate a package inside, and the tunnel just stays with you.
Kind of like this?
Yep.
Huh. What does everyone else think of that? That's an interesting idea.
I can't really visualize it. I'm trying to think of it.
The other thought is maybe you have a driving tunnel, right? And you can open up your trunk in the driving tunnel, and that way you put packages in the trunk.
But like for picking up your package.
You know what? Honestly, trust me, I'm way above you on the why don't you just pick up your package idea. Like, why don't you just pick up your package? Why don't you just go to the store to get pizza? But like,
that's what I was thinking. Can I actually like give you guys a little business pitch?
Yeah, go for it.
Okay. Now imagine this. I don't know about you guys, but I used to work in Long Beach, and I'd have to drive there at 9 a.m. in the mornings, and the 91's a bitch, right?
Yeah.
And I'm almost always late for work, but
Yeah.
I always see like a Del Taco and a Denny's and a Carl's Jr. and shit right on the off ramp right there, but I can't get to it because I'm stuck in bumper to bumper traffic. So what if this thing just comes down the on ramp? Like, you know, you could just order it on your app while you're like stuck in bumper to bumper traffic, and it comes down the on ramp and it goes over all the cars and delivers food to people while there's, you know, just sitting there.
I mean, like, I see that, but then like we also developed drive-throughs, and like they're still packed. You know, I don't know.
But this could be a service that you buy for a premium.
Yeah, sure. I just think in general, like, I don't think we should care about what we're selling. It's more about the idea of moving items from one car to another, like
Oh, true.
You know what I mean? Like, I personally don't want to focus on, oh, you're moving food, you're moving X. It doesn't matter what you're moving. You're moving something. You're moving shit from A to B. Okay, how do you move shit from A to B when A and B are moving? That's
Fair.
all we need to do. We need to figure out how to move shit from A. That's our problem statement. How do you move shit from A to B when A and B are moving? It really is what it, you know, that's basically it. Because en route refueling and en route delivery are both similar aspects. I was looking into en route delivery as well, or en route refueling, because that's actually pretty common in like planes.
Yeah.
But the way that in planes, the way that works is like they drop a cable and like it has this like aperture and the pilot has to drive, right? So like that's kind of fucking hard, you know? But like if you just need to refuel, like let's say, okay, you know what would be great, right? Let's say we have autonomous trucks, right?
Okay.
Doing freight. Autonomous trucks can drive for fucking ever. But let's say maybe they're not electric, you know, like maybe they're not electric because like electric motors aren't strong enough, batteries don't go enough. So we're still using fossil fuels, but AI is advanced enough to be self-driving, right?
All right.
And we need to refuel these trucks. That's the same problem. And you know, it's just a billion different ways to label the same problem. It's just all about like what kind of mechanism do you want to make.
Yeah. Okay.
So really, like, I think tonight we need to say, okay, we're getting something from A to B, and how do we want to do it? And then, like, it's either fluid transport or solid transport, you know?
Yeah, we've already put more time into solid transport, and it
Yeah.
seems to still be the easier one to go for. But what do you think?
I agree with you, because if you have fluid transport, then you have to say, okay, well, then I need to devise a pump, right?
Yeah.
And then I need to run that pump. And then I need to calculate pump head. And I need to calculate the losses of through the pipe or through the hose
Yeah.
or whatever.
I don't
And
know
then
about you. I'm a bigger fan of Newtonian, like
I
kinematics, than I am.
motherfucking hate fluid dynamics, okay? I fucking hate it. Okay, the only fluid dynamics I care about is like CFD for race car aero. Okay, that's
Yeah.
it. That's it. Okay, and like, don't tell me about no fucking pipe flow, energy balance. I don't want to be an HVAC person. Leave me alone.
Flow is compressible. Oh shit.
Oh, I also like the turbine analysis stuff too, but that's just because it's turbochargers and like compressors. It's not, you know, it like. Other than that, So solid transport is our idea for sure. Or like semi-solid, meaning like it could be food and like something in a soft pouch, so long as it's not like a liquid in a tank.
Okay. Do you think he'll care if it's? Do you think he'll make us differentiate between food or just a general package, or do you think we could just say general package and he'll be fine?
I don't think it matters. I think either one, they work well enough. You know, like, you know how I would design that front plate idea. So if that's the winning goal, which maybe we should talk to him about a couple different ideas. Maybe we should have a 2-idea presentation. That way he can't tell us, oh, this one's garbage, go do something different. We could say, okay, well, like we have 2 ideas and we're leaning more towards A or B, and that'll develop over time, right? Because the statement of work is the same, just the philosophy of how you do it. There's either above or next to. That's it. It looks like those are either we either come in from above or we go in right next to you.
Correct. So should we focus more on the statement of work?
Hey guys, I was gonna say, if you look at that more prelim designs tab that I just added, I went ahead and added a drawing of mine. Hopefully it will load up.
Yeah.
You can go ahead and zoom in on it.
Yeah, definitely.
So
and
I like roughly guesstimated the dimensions. I'll go by a picture through picture. So the top left is a rough estimated of the window dimensions. And I assumed it was like 28 inches by 20 inches. And after hearing Daniel's input, that like his, what was it, your Volkswagen? What was your Volkswagen?
My rear window, because I used the rear window just because it was smaller. So I was like, okay, like what if you wanted to have the rear be a, you know, whatever. So
yeah, so then
it was 23 by 15, and so your 28 by 20 makes sense for the front door.
So then I was thinking about which side it should be delivered from, and I went ahead and went with the passenger side just because like I don't know if the like say if the plate right there I made it 24 by 24 inches, like I just added that. Just ignore that. But say if the plate is 24 by 24, then it's gonna kind of come in the way of the steering wheel. So I figured like, okay, let's just have things delivered from the passenger side of things. But if you look, starting from like the way that the car door is framed, I have these like two suction cups holding onto each side of the car door, and then we'll have these like linkage system come up and it'll support like the base plate that's going to be moving. And if you look at the top right hand side, you can see like the support stand go across the plate horizontally. It's like it's that thing where I have a labeled support stand at the top right, and those support stands, they could essentially have like 4 rollers right there, and those rollers could be going across these like ball bearing sliders type thing, and these ball bearing sliders will be attached to the moving plate, and the moving plate can just be simply moved by a simple gear drive with a simple pulley system going in and out, in and out, in and out. And as far as like the tentacle tube and having that being controlled, I really like Daniel's idea of a hamper, like how it just expands and unexpands and whatnot. But I mean, that would require so much more input. Like we would require more thought into that tentacle tube, you know? It's like
Well, the
it's like
tentacle tube really, I think, is more just how do you protect
yeah.
mechanism from the environment. And realistically, if you just like, depending on how it moves, it doesn't really matter, because if it's hooked up to the front of the tube, if it's hooked up to the front of your mechanism and your mechanism moves out the window, then the tentacle tube will move out the window with it. It just goes around it. Like it's not really essential for anything design wise. It's just our good idea for how the fuck to get around going through the like atmosphere or the exposed environment, like just how to shield us. Like that's our idea. So like for me,
so basically this design, I just try to keep it really simple. Just those suction cups holding onto the side door. We have these 2 linkage systems, these frames coming up and holding up these support stands. And these support stands are going to have rollers on it. And we'll use a double ball bearing mechanism system that can slide in and out. That will be attached to the bottom of the moving plate. And then simply the way that we can just drive that moving plate is just by a simple motor with like some sort of gear drive. And like the main idea that I got from this was just looking at a simple window regulator motor. I mean, windows go up and down, up and down, up and down. So why not just mount that system like horizontally, use those pulleys, and just have the moving plate go in and out, in and out. And like,
so I like that idea.
Yeah.
But again, I mentioned earlier that like it's up to 6 feet, right? So like if the car is 6 feet, we would need to have like multiple stages, which I'm totally about. If that's the case, because my first idea or like my
wait, what's 6 feet exactly? Like the
highway lane is 12 feet wide apparently, and a average car is 6 to 6.5 feet. So you could be delivering and we know at least on Nissan Leaf is small, so it's going to be in that 6 foot width range.
Yeah, but we don't have to necessarily keep the car like.
But potentially, you're potentially going up to 6 feet.
Because weren't we saying like the magic number is around 3 feet? I mean, we wouldn't want to be working with any other distance than like 3 feet, because we could like, I don't know, we could like design our system so we don't have to deliver items of 6 foot, like 6 feet across the highway. Because if we have like a 3 feet distance between both cars, and it'll work that way. I mean, like 6 feet, like you said, it's really hard to work with.
But 6
like
feet,
maybe if we could design our
6 feet means that both cars are centered.
No, I know. Both cars are centered.
That's the ideal case.
That is ideal, but I mean, in reality, it's like, how are we going to develop something that can go 6 feet across?
But the thing is, if we develop something that goes 6 feet across, it means we have a lot more room for disturbance, because the thing is, think about it this way, right? Like, think about
why not just program the autonomous vehicle to just scoot over towards the left-hand side of the lane?
I mean, you could, but then
just make sure that the left-hand tires are like literally on that freaking like lane marker, and then bam, we're working with 3 feet of distance. Just keep it safe.
I don't mind that, but like the thing then is like, how much are you really gonna say is like, oh, it's up to the like it's just up to the autonomous car. Because if that's the case, we could literally just say, well, the autonomous car has cameras, and therefore it always goes the same speed as the car next to it. And the car has autonomous cameras, so it always stays, whatever width we want it to. And we could just say that the autonomous car has X, Y, and Z, and make like all the assumptions, right? But the reality is that, like, if we were actually designing this to retrofit into autonomous cars, we would not want to spend all the money and all the time going through this just to find out that the systems aren't good enough in the cars to actually maintain what we assumed. And then the cars start fucking crashing into each other because they start trying to maintain the distances we specify, right? Because we would have to feed them commands. And then we don't have the necessary length. So we don't actually, our system doesn't even have the ability to, for like the margin of error. So like it actually can't do much with disturbances. So that's my only real concern with saying that, like, oh, let's not worry about 6 feet, let's do 3 feet. And because like you could just start jumping to a lot of conclusions, and then you dilute the aim of this project potentially. And like we do have all semester, this isn't like it's due next week. I think we're all very used to getting things done very quickly, and I think that it might not make as big of a difference as we think.
So then, like, what would be the plan of action here? Should we just go with the standard 6 feet distance and then make our, like,
It's
I
only
don't know, because then it
the
just
distance between 3 feet and 6 feet is not much. And if you think about it, like if the car's width is 6 feet, right, then that means that the interior space is about 4 feet, right? So if you have two,
no, exactly. I know
or
you're headed
three,
towards.
if you have 2 or 3 of the
But what
platforms,
should we do,
and
Daniel?
they
Like,
just
why
slide
not
right
make
over
our
each other.
system, like, deliver items within 3 feet of distance between cars, or 4 feet of distance? I mean, we can't.
we could, but why? Like for 2 feet, I feel like we're not even gonna like save ourselves any headache. We're really not. That's just a parameter, It's just a parameter. That's all it is. It's saying like it doesn't matter. It really like it might matter. The only thing it matters in is like sizing your motor potentially. But so I'm just saying like why I personally don't want to limit our scope in terms of what is realistic, just to potentially make things easier, and then at the end of the day not even make things easier, you know what I mean? Because that only affects this first little design hump. Later on, the controls that we develop, is it going to care if it's 2 feet or 3 feet or 4 feet? No, that's just the why desired for it. Like so my thing is like I personally prefer to work with the actual numbers, just so that way I have a good frame of reference. But if I understand if you don't, and if the other members don't, then that makes sense, and their input's valued in this case.
Okay, then say we freaking make like that moving plate going in and out of the car windows like 6 feet long, 2 feet wide.
Well,
I mean,
my thing is,
it just sucks because like we're gonna be having to deal with, like you said, like more disturbances in our model. We're gonna have to deal with like just more deflection in general, and just having to make it more sturdy in general if it's going to be longer and sitting longer.
As far as controls go, a little bit of deflection is not a bad thing, because think about this: a sheet metal, like if this is only carrying 50 pounds or something like that, we said like a very normal OSHA number for a box.
Yeah.
That's not very much. So if you think about this, like look at a drawer, right? Because I think you talked about ball bearings, and to me it's reminding me of a drawer. So let's say that there's a drawer, you open a drawer, right? And you pull that drawer out, and how it's like have you ever opened a drawer that's really long and you're like, oh, like no way this thing is going to open that long.
No, I get you, yeah.
And because it's like staged, so you have like
you're saying the idea of like having that extending plate be really long is still realistic, right?
Yeah, it's definitely realistic. What you would do then is maybe so maybe, because I also thought about the idea, and then I thought like, okay, like the plate, since it's just a plate, you might not have friction, or like, and you're trying to suck it back in really fast per se. Oh, then the box might slide out the window, right? But then you could maybe introduce like a gyroscope. Or I'm sorry, like just a single motor to control the angle of about the if you're moving along like in and out the window, right?
Yeah.
The axis that is mm, it is it's the it's in like the front to back direction. You're tilting about that direction.
Yeah,
Right.
yeah.
So that way you could then control, you at least have one more variable to control potentially, which gives you more disturbance response because it now means you could have a faster like take in or take out speed because you could tilt the plate. So that's just a thought I had. So you could have the slide mechanism and that's
I know what you mean.
goes,
Yeah,
goes
yeah.
in and
So
out.
you just have that plate, just tilt the item, and then just have it fall into the car.
Kind of.
But
And
then
then
that is like, we would have to make our like our little like system model be probably like
so the
1 feet,
way
like 12 inches above the car window, like 6 inches above the car window.
yeah,
But
something
then we also limit like the amount of storage that we can put onto that moving plate.
well, yeah, kind of. But then think about the moving plate is the move. All three of these ideas are all valid. Like the moving plate, so long as the plate is in sections. Because the thing is, if let's say you drive this with 3 DC motors, right?
Yeah.
Each plate has a track, like it's a geared, right? Or
Yeah.
it's geared. So and it has a DC motor connected to that.
Yeah.
And then so we control all 3 of those DC motors. We would probably just make them all move at the same speed. So that way basically your linear speed is just 3 times whatever the like the linear like you just move 3 times as much as the motor, like you're moving 3 times as fast as the motors are, as one motor would move you, obviously, because all 3 are moving at the same time, or all 2 or all 4, however many sections of track or sections of slide, right?
Okay.
And then that's just one direction. That's just X, right? You're just controlling X direction. That's nice. We like that. And the thing is too, if in the mechanical design of this, let's say, yeah, maybe you wanted a gear, right? But you don't necessarily need a gear. You could also do a track with like a rubber wheel on it. So that way you have some disturbance built in because now your tracks are not perfectly constrained, which now means they have some slack to, vibrate around, and they will inherently absorb some disturbance force. You feel me?
Yeah, I do kind of see where you're headed.
So
It's just
that's
like, we're probably gonna have to like, I don't know.
I'm just trying to think of all the potential constraints, To me, I really initially was trying to do this, that the idea that you were talking about, just like something that slides out, something that, a track or rail, something, and I was having a lot of difficulty with it. I was originally trying to do a rail that was mounted to like a 2D arm, right? Or like a 2-link arm. So that way it would just like, because a 2-link arm, you could have a path and then like, and then they would just like go along it.
Yeah, but then why not make it happen, I mean, if like,
you could make that happen. I was just having a really difficult time with it because I was like, okay, well, if I have this rail, right? Well, I was playing around in SolidWorks, which, is always inherently frustrating sometimes when you're trying to conceptualize things. So maybe that's why I stopped. But like, I don't know. Have you guys ever seen? I was thinking about roller coasters, right? Have you seen how roller coasters will use like 2 or 3 wheels to like stay on the track, and they do all crazy sorts of shit?
Yeah.
Well, like if you had 2 rails, that means you have and you have some factor of misalignment because like your wheel is constrained in the 2 tracks. Like it's basically, and then you could potentially have some movement. But I don't know. I was just like thinking about that, and I was like, okay, this like, there's a couple things that don't make sense, right? Like if your box is big but these arms are thin, what happens if the path of these arms doesn't coincide with the path of the box and you go to swing this shit out the window, right? Or you go to move
Yeah, the arms are like
arms out the
hitting
window,
box.
and then guess what? You hit the box fucking hits the window or hits the inside of the car, and it just like because we didn't think like, oh fuck, what if the box hits the window, And I'm just like, damn, that doesn't make any fucking sense. I don't care, like, and then I started kind of giving up because I was thinking about all these situations that like I just didn't want to deal with, and that's kind of how I ended up on that continuum motor, because to me it was like, okay, that thing will just snake in and out of anywhere. And then Tommy was talking about the being on top, and I like that too. And I do like the slide idea. I think any three of
I'm
those.
always on top.
So I think any three of those could realistically work, and I think it's really just a matter of thinking about which one is the most feasible. And that's what this discussion probably should start transitioning.
If we went with the Continuum robot, how much more would our general system cost compared to like, I don't know, say like Thomas's or like just a simple sliding?
It's hard to say because
I don't know. I've never worked with stuff like that. Have you?
so the continuum motor, I think, is more. So I think each project has different focuses. I think the continuum motor is an easier mechanical design because it utilizes springs and cables, and all it really does is you're just inputting a force on a spring, on like a stacked spring system, an assemblage of springs, and then basically you would just be looking to see, like, you would go from one spring plate system to the next, right? And the more spring plate systems, let's hear Vincent's idea, because before I go off on too much of a tangent. Go ahead.
Just finish your thought.
I was just gonna say that, like, the more plates you have, the more resolution you should have as far as like angular accuracy or whatever, just because it's another node. So basically, like, if you think about the continuum motor, it's just a daisy chain of spring mass assemblies. That's what it is. It's multiple spring mass assemblies that are positioned in such a manner where there's cables acting on like the spring mass system such that it remains horizontal, right? So basically the tension in the cables initially would be a zero value, right? And we would just say, what does the tension spring and the compression springs, because the tension spring will keep it far out, but it doesn't have a lot of force. Like, it's not a high spring rate. It's this tiny little wire diameter, and it's like, pretty like small pitch. And then the other ones are just compression springs. So if you have the same compression spring for every single one, your spring rate's the same as having one long ass spring. It's just you get a little more resolution because of like the nodal aspect of it. So really, it's just, we would have to say, okay, well, how many nodes would we want? The more nodes, the harder it is, I believe. So I would probably stick to around 3 or 4 and no more than that. And then it would be like, okay, well, what does the force do? And really, you could just say that the force acts at the end plate, right? More or less. And it puts a moment on it.
Yeah.
So,
Yeah, I'd say so.
like, you could model it relatively easily, I believe. So the controls, and then it becomes more a matter of, okay, well, let's see what the natural response is. Okay. And then let's play around with the root locus. Okay. And then let's look at the Bode plot, and let's look at the phase response and see where our phase margin is and our gain margin. And then let's develop, after we develop our PID tuning and kind of figure out a controller for the natural response. Okay,
is
now
PID really the only one to use?
I mean, there's other. So like right now I'm in discrete controls. There is discrete control. There's PID control. There's state space modeling. There is a lot of variation of methods.
I see a lot of YouTube videos about PID, though. I feel like it's the most
PID is the most common control mechanism because it just uses your simple principles of physics. So
I see. Sorry to interrupt.
No, don't worry about it. State space modeling, from what I've heard, is the best for 3-dimensional environments.
Oh.
So
okay.
maybe that. So that's another thing too. Think about this. If we want something more controls focused, which might be beneficial because we're all online, well, we could do discrete control. We could do PID control. We could do disturbance response for X, Y, Z disturbance. We could do the natural response to step response, the impulse to response to this, to that, to everything. And we could really go in depth with the controls analysis. Or we can keep the controls part simple with some, and then work with more issues potentially on the mechanical design side of things. And that's really just a matter of what you guys prefer. Me personally, I'm a controls guy through and through.
Yeah, it sounds like it.
So I'm taking right now Tarek's digital controls class, and it's making a lot of sense.
Which professor?
Tarek El-Shargway or something like that. He teaches 4990 digital controls.
Oh, I haven't heard of the guy, but sounds cool.
Yeah, he's an Aero guy, but he's teaching an ME class for the first or second time or something like that. Or
I see. Okay.
So I don't know. Let me think. What else? Well, when we think about the Gantt chart,
Wait,
right?
Vincent.
Oh wait, yeah,
Vincent,
Vince.
your idea.
I'm sorry, your idea. Let's go here. This is why I had told you to go.
All good.
Sorry, I'm just working at a million miles per hour lately, and I'm just like so out of it.
Can you stop sharing your screen so I can share my screen?
Yeah, go ahead.
Yeah.
Please.
So sorry.
Thank you. All good. Don't
Yeah.
worry.
Dang, it doesn't let you guys share screens at the same time.
Also,
No.
before I say this, I might leave because it's getting late and I have to be somewhere in the morning tomorrow.
Yeah, you're
So
It's all
good.
good.
I'll message you guys when I leave, but I'll probably watch the video to catch up. But
Yeah.
back to my idea. So I kind of
So-
thought of it differently from most of you guys because it sounds like you guys want to deliver a package from a moving car to another moving car.
Mhm.
Yeah.
And then I thought it would be different because I thought we were my idea was take like a normal like car like the Nissan or like a regular sedan because I drew a sedan, and then make it autonomous so it can deliver packages from point A to point B, C, D, E, F, G. So, and it would be kind of like a pickup system. So, essentially, like you would load up the car with packages. It would drive to said destination. It would notify the recipient that they are there. They'll come out, scan like a QR code, and then the driver window would roll down and like their package would be there, and this is grab and go. That's my idea because I thought that's what we're going for, but it seems like you guys wanted to do like moving to moving vehicle.
No,
I
yeah.
thought that was
Well,
what we were required to do.
Yeah,
Oh, it
Vincent,
was-
you probably missed out on the like important Zoom meeting that we had between Dinsmore. But essentially, yeah, Dinsmore did want us to have the vehicle in motion.
Yeah, Dinsmore kept talking about a pizza delivery. I think he was hungry.
Oh, okay. For some reason, I thought he meant like an autonomous pizza delivery system that
I mean,
didn't
Yeah, no, I
require.
get you. Like some sort of system where you can just have like a pre-allocated destination, and no one has to drive the vehicle, and then the only person is going there is just gonna pick up the package.
Mhm.
yeah.
But
Oh, so he wants it moving.
yeah, he does want it moving, which is
Yeah.
the good
Oh,
part.
okay.
Yeah, there's
Okay, never mind.
there's like a bunch
My
of
idea
control.
scrapped then.
That's the bitch part about it. It's like crap. How are we gonna
Yeah,
make sure that this system is sturdy while in motion?
Yeah, because while you guys were talking, I was like, I didn't really see a practical. I mean, you save some time, but there's not really a practical sense.
No,
of,
it's
like,
not practical at all. This
picking up
is
like an Amazon package as like
That's
it's
the
moving. I
fun
feel
of
like
it,
it's just
man.
That is
Okay.
the fun of it.
it's really not think about this. Okay, you're going down the fucking freeway, right? And you're like, oh
Yeah.
god damn it. Okay. Your boss calls you, says, hey, we have a big meeting with XYZ person. You need to get some donuts or else you're fucking fired, right? This is what I was telling my sister. Let's say you need to get donuts or else you're fired. But guess what? You're not gonna but he says if you're late to this meeting, you're also fired. But guess what? You're gonna either be late to this meeting with donuts or you're gonna be on time to this meeting without donuts. So you're fired either way, right?
Oh,
say-
okay.
Let's say this
okay.
is the theoretical, right? It's your job on the line. That's your paycheck. And damn, you're gonna want those. So you're gonna like so you're going to order donuts, right? And then this will intercept you, right? So like if you order something, ideally it should be coming along your route at some time. Because if it's not coming along your route at some time, why the fuck is this thing going to be playing catch up with you? Like it would never be for that. It would never be to be like, oh yeah, you're in San Diego and I'm up in Oregon and you're going down to Mexico. I'm gonna deliver your package as you're driving down to Mexico. Like how the fuck are you gonna get to me? No,
Yeah, that's
you know. So I think like definitely an assumption we should make is that it's local only.
Yeah.
And it
I
has to
mean,
be en route. It has to be en route. So it would be
That's
like,
true.
like that way it makes sense. Otherwise it makes no sense.
I always kind of saw it too as like a potential for like, for example, like you were saying right now, it was like local, like a local kind of delivery only. Say for example, if you have one of those like those Amazon vans, right, kind of going around delivering packages. Say for example, a new package kind of comes into the post office rather than have like or like to a delivery warehouse, rather than just have it just like wait there until the van kind of comes back while it's making its delivery route through like a certain area. It delivers the package, so it kind of saves the time for it to come back to the warehouse location
Hey,
and kind of deliver it on route.
I'm not gonna lie. Who said this had to be a car? Why can't it?
Yeah. Exactly.
Why
Didn't
can't?
we
Hold on.
say
Hear
that
me
we
out.
didn't even
Hear
have
me
to
out.
worry about
Whoa!
just like use like a 3-wheeler or something like that. It's up to us. But
Okay, no. Hear
at the end of
me
the day,
out. Think about the 3-wheel idea, right? What if you have a bike, right, and it has a sidecar, and the sidecar is just like a little fucking box trailer that holds packages, and on the back of the motorcycle, because the motorcycle is hooked up to the sidecar, you just have like a 2DOF arm. So that way, this thing is so tiny, it just goes right up next to it, and the arm just swings the fuck out and delivers the package. Soup. No nothing. No tunnel. No nothing. It just from one to the other because it's just like a small distance, and it just perfect.
but question, what like can we find a bike or like some sort of 3-wheeler or some sort of open vehicle that is also autonomous, like in today's market? Or like what would we use? Like obviously like would we just end up making like some sort of modeled vehicle on our own creativity, Or would we be able to like find something in real life that actually like portrays that like open vehicle system?
I don't know. My thing is like, okay, so like back to this, where do you deliver from? If you're on top, that's the shortest distance, but getting up on top is the hardest thing to do, right? We know that you're always on top, Tommy. Because you said it earlier, so I had to reference it. And then
You learn quickly. I like it.
okay, so and then like if you come in from the side, like damn, okay, that's a decent amount of distance, but at least you didn't have to get on top, so you just have to go next to him. That's no problem. Anyone can do that. And then the bike, though, the bike is like, okay, you can get next to one, and you could do it however the fuck you want, right? Because a bike is tiny, and that's no problem. And now, like, oh, a bike in a lane, well, now it's super feasible that because this thing has so much more room to move around in its lane, we could do deliveries at 2 feet long, 3 feet long all damn day, So that's where like what your mechanism is and what you're delivering on, why that matters, because it determines your parameters and really nothing else. Like who cares about it? It's all just like what mechanism and what are the parameters, and like that's just driven by the design. So I don't know. What is your guys' input into that? Those like therefore comparing those three, like modes of transport essentially. Like if you have a slide rail, you come on top and you have like a gravity fed tube, or you do like the continuum motor, or you do the slide rail. But the continuum motor and the slide rail are the closest two ideas, right?
Yeah. I was gonna say something about the continuum motor. Oh yeah. The idea of using the spring's potential energy to also reuse it in the mechanical energy system. I like that idea a lot. But
yeah.
Like, how well could we model that system? I don't know.
So here,
like obviously you'd be able to like take charge of it, but like I don't know.
So I was kind of like looking at that and a little bit. And let me see if I could pull up that file. So I thought I saw something here that was.
Also added like some more pictures to my design just to get like a better explanation across.
Okay.
But continue on, Daniel.
That there's like these because when it said it's like in this model that I posted, there's advanced real world models that uses like a state space controller, and there's a 3DOF translational mechanical system. There's the nonlinear proof mass actuator. Like there's a bunch of stuff that could potentially be our answer, because I really looked at this before I when I was trying to think of ideas, because I said like if I can't figure out how this is going to be modeled, then I really just can't do anything.
Could we so I think the biggest problem everyone's having is getting the package into the car. Could
Yeah,
we
yeah,
just
true.
could we somehow make the package magnetic so we just stick it on top of the car? Would that solve like the
So
hardware
I
problem?
also had another idea, and I don't know if this is a good idea or not, but it utilizes the idea of the slide, like the slide table, but it also has some state space control, because it would be that, and it would be, may I share the screen real quick to show you guys the SkyCam control modified thing? It would just be like an inverted version of this.
Okay, go.
Okay. Oh,
For it.
am I? Oh, cool. Let me
Sure.
share a screen, and let me go to Advanced Controls Project, Google Share. So if you could see that SkyCam control, if you flip that upside down and you relook, and the motor and pulleys could be mounted anywhere, it doesn't matter, right? So then that's just a square frame. And if the square frame is mounted like near the top of the window, say, and then you have where instead of a TV camera, you have again like a bag or a trolley or whatever holds your package, then you could go from outside the window to inside the window pretty easy. And then the thing is too, like the motor and pulleys give you precise control, and then the slide boom or whatever, like the thing that goes out the window with this thing on it, wouldn't have it would just be like, it could be big and it could be heavy and it could be it could be robust essentially, because like it only does a part of the movement.
Would
It
this
only-
allow for more than one package to be delivered at a time?
I mean, anything could, like one package, more than one package at a time. It's just a matter of how do you get them onto it. So like, let's say like,
Yeah, like who's gonna mount it or like?
yeah, exactly. So
I see.
yeah. So, but let's say like you had, 5 packages or whatever in the car, right? And like, let's say they're all in like a metal cage, right?
Uh-huh.
And that instead of a TV camera mounted where that SkyCam control is, it's a
Crane.
yeah, it's like a crane. Exactly, it's like a crane, and it just has a magnet on it. So it just, when it comes in, it just picks up the next package via magnetic force or whatever. We're not going to worry about how it picks up the next package. It does it.
Yeah.
It's
We don't need to
witchcraft.
worry about that.
We don't need to worry about it. It's witchcraft. Who cares? Okay. And then we could use the SkyCam control, because it, again, like I said, it doesn't matter where you mount the pulleys and the motors. This system is still relatively accurate. You might need to change some sort of gain or whatever, but you could use that control loop. And then it's just a simple translational system, which is just one direction. Guess what? That's just a motor control. That shit easy money. How far do you want to go out? Okay, boom. You got to spin at this speed, and you want to do it.
But you said it would be kind of like the inverted SkyCam.
When I say inverted,
Yeah, what do you mean?
when I say that, I say, so you see that the motor and pulleys are mounted on the floor there?
Yeah.
Yeah, they would be mounted on the roof essentially, and your package would be hanging over this crane.
Mhm.
And then the pulleys, the motor and pulleys, is what we would be actually controlling. So we would say that, like, basically, because you know how we're saying like, oh, we got to go 6 feet, we got to go whatever feet. The crane deals with that. It just goes straight out the back seat, goes straight, okay, goes X direction, or it goes from one to the other. And then this motor and pulley, we're gonna say that is what does all the real like technical work. We've split the work. Okay, we got you next to the car, and that's pretty easy to do. We could keep that thing about a foot away from the car or whatever and still manage to get this cart in, because the thing is, if we start at the back of it and then we move it forward, we naturally just kind of swing it right into the car. We can stay away a little bit from the car and it'll pop into the car. You feel me? Because like you have a magnet, like you just got to swing the package into the car, and then like once it's in the car, like once you pull the magnet away, it's gonna drop off, because you have a disturbance force now. Like, so once you can swing it into the car, so that way you could stay like a couple inches away from the window, and that way you don't go boom boom break.
Yeah.
That's another thought. That was a thought I like didn't play with at all. I didn't play with it, but it's not a bad idea. Like, you could have an electromagnet, right?
Yeah.
On the end of it. So the electromagnet, you just turn the electromagnet off and it no more current.
Magnets, bitch.
Magnets, bitch. And then like the thing is too, like, since we would say like the crane, it only moves in one direction, and because it's robust, that means it could have big powerful motors, which means that disturbance response for like needing to evacuate the package mid delivery per se, that's all handled by the by that big crane. It just zoop right back in, and then the TV camera, or I'm sorry, the little Skycam control would only job it'd be to stabilize the package during that maneuver. That's it. So it doesn't fly off. That's it.
Huh.
So it would just try and maintain the position. That's it. It would say like, oh, don't let me move back, don't let me move forward, don't let me do too much,
Okay. That's okay.
I don't know. That's just a thought.
Yeah, it is a good thought. I mean, like, it just sucks because, like, I don't know, Dinsmore is probably going to expect, like, something of us for the end of the week.
I mean, just a pretty simple but like concrete product or problem statement, project statement, is what
I think
we need.
Exactly. We need a concrete problem.
As long
statement.
as it's fundamental, bare bones, but stable, I think you'll be like, fine.
Exactly. I think we
You're
have
saying that, like, as long as we just, like, detailedly explain the problem in one page, we'd be fine. Like, we don't have to go too in depth into our design yet.
Yeah, we could say just like use an autonomous vehicle to deliver some general item to another car.
Yeah.
Allow both cars moving, whatever.
Exactly. Basically, all we'd be doing is, well, of course, we're stating the problem. So we're saying that, like, our problem is there's an autonomous moving vehicle with a package delivery system. And that package delivery system has some sort of system mechanics yet to be determined, yet to be designed. And then we're going to talk about...
True. Yet to be determined. That is true.
Yeah, yet to be determined, but then we could talk about potential options because we have been looking at them. So we could talk about...
Exactly.
We could talk about the approach. So we could say you can come in from the side or the top, more or less. That's really your only options, like
True.
The side or the top. Coming in through the back is kind of hard, unless you want to like open the trunk. I don't know how you would do that.
Coming from the back, that'd be funny. That'd be pretty difficult.
Right? You just
I
ram.
mean, you guys better not be thinking about anything else, but.
I mean, ram the package right into the trunk. There you go. You know how you delivered it? By crashing.
LMAO.
What if it crashes directly through your windshield?
Right. Okay. So yeah, and we could talk about like the distance. We could talk about the parameters, meaning like.
What if we expand, like you said, Daniel? What if we expand our scope right now really quickly, and we try and find like some sort of autonomous bike, some sort of vehicle that has open windows, that's open to like the environment.
That's open air?
Yeah, that's open air. Yeah, essentially.
Okay. You know what's open air? A fucking pickup truck. Okay, a pickup truck is open air. We could just say like Tesla swap F-150.
LMAO. Only if.
Tesla swap F-150. Okay, fucking, this is America. Huh? Tesla swap anything. It doesn't matter. Tesla swap. Okay, look. You know how like the most bulletproof trucks are those old Toyota trucks, like the old Toyota 1-ton pickups from the 90s.
Yeah, yeah. It doesn't
Motherfucking
even
one
have a
of
model
those. Okay, we
number.
could just say it's one of those, so it's never breaking, and it has a Tesla swap. Okay, like it doesn't matter. It doesn't matter. If you want to go open air, we could just say this is a pickup truck. Fucking mount a crane in the back of the pickup truck and swing the bitches in there. You know, like really,
Yeah.
like we could do whatever we want. It's just more about like, what do you guys think is feasible? And but like I also like the idea we could work with the truck too. Like that's what our problem statement. We're still working through that stuff. But I think we definitely
But if we could find like, I don't know, even a better vehicle, like a perfect, or a vehicle that would make this problem easier, that'd be wonderful. But like,
I'm
we're
gonna
kind of
stop
like,
sharing
we
real
are
quick.
kind of like using a bunch of time here. So like, I don't
Yeah,
know.
no, we're spinning our wheels a little bit here because the thing is like
True, we are.
it's because the thing is like we all have there's various ideas and like the thing is we have no clear cut winner. So I think we have like clear cut favorites, but they all have their own drawbacks. What?
I'm just like looking at like different like vehicles right there out there in the market.
Oh,
But it just, okay, the thing is, if we use a smaller vehicle that is open air, that's a 3-wheeler or say even a 2-wheeler, like a freaking, like, I don't know, like a motorcycle or something like that, we change our distances of like you said, the 6 feet between each car with using the practical like lane distances, like we change those distances and then our problem changes completely. And then we'd have to cover a lot more distance, or then we'd have to dive into the controls aspect of the vehicle and have it like shift over to the left-hand side of the lane. That way we could get a closer distance.
yeah. So the thing is too is
We
like,
would have to find like that perfect vehicle almost.
well, maybe, but the thing too is that if you like, this is why I'm okay working with the worst conditions, because I know that any like the system will satisfy any condition, so like that makes me comfortable, of course. But I also understand the notion of let's make the parameters harder, right? And the thing is too, though, think about this: the mechanical system can always change later. So, like, okay, for example, let's say we use the slide, right? And let's say instead of 3 2-foot slides, like, so let's say the distance goes from 2 feet to 4 feet, like, or whatever.
Okay, yeah,
We're
yeah.
doing, like, in that case, all we're doing is controlling a cantilever beam. That's it. 3 cantilever beams in series, basically, like kind of mounted to each other with a pin, or with the roller. Really, it's with the roller,
That goes in and out.
and it has a normal
But
foot,
it's
and
like,
it goes in and out. Yeah, so
but
like
it's also like hella long. That's why it's like modeled as a beam.
exactly, it's hella long, so it's modeled like a beam essentially. And as the beam goes out more, you get more load or whatever, and like, but really, like, what does it matter? Guess what? You take one, like, let's say again, like I said, if you have a 6 foot, if it's 6 feet and you have 3 2-foot sections, well, shit, you need 4 feet. Okay, guess what? Now you got 2-foot sections, and you're good. Okay, nothing really changed. All you did was delete a plate, maybe change some numbers in like a MATLAB file, and change like a SolidWorks file. So like, it's modular in that degree, and I like that. That's why I like, because the same thing can be done for the what's it called, robot. Because if you have less springs and less plates and a shorter tension spring, again, same thing. It's just a modular design. So like, I'm cool with those aspects. And then the nice thing about coming in from the top is, guess what? What design do you have besides just one system? That's all you need to do is go from A to B. And A to B is like a very small window, because they're in the same. Now you only have to go travel within a plane of motion, right? So like, if you say that the window is in the XY plane, you just have to travel from one square of the XY plane to another square of the XY plane. And that's much easier because you have potential energy to help you.
I see.
So again,
Wait, when we do create our Gantt chart, we can also like make the project scope timeline be like, have an official like prototype model by like this date, like say like
I
late
personally,
late October, November, you know, like
yeah,
around-
yeah, I would personally like to see us start getting into controls before we leave for the semester.
yeah, yeah.
Just
Oh,
starting
yeah.
to kind of, I would like to, by the end of the semester, I would like to be looking at the natural response and maybe start developing some light PID control, light. Because the
Okay,
thing
for
is,
sure, Vincent. I think I
'cause
get it that already.
the thing is that that like whatever we look at is not a CISO system. Potentially, it might be a MIMO system. So like we'll have to develop CISO controls for like each individual little like quote unquote subsystem of the system, and then integrate a MIMO system later on. So like, you know, like there's plenty to do next semester after we hash out what the fuck this is and how does it react naturally, like with no control.
Agreed. But we can get the design and maybe get into controls this semester.
Definitely. I agree. Like definitely the starting stuff.
But we really need to cast a wide a net as we can right now.
Agreed.
Yeah.
But I think like as far as like Gantt chart outline goes, we kind of have an idea for how
Yeah,
it's
we
going to
do.
go.
Yeah.
So that's good. It's more just about having concrete titles on things and having some more
Oh,
direct.
should we figure out what titles we want to give certain things
I mean, like lightly, you know,
next time, maybe?
when I say like what titles, I'm saying like, you know, we have blocks, right? Like blocks of time, maybe like 3 weeks at a time or 2 weeks at a time. I would say 2 weeks is your goal time and 3 weeks is your stretch time, maybe. And then that way you have a week always to kind of like phase into from one scope to the next. So like right now we would be in like phase 1, which is like, you know, figure things out. And the next thing is phase 2, which is like get like a physical system kind of like drawn up more or less and kind of start developing a transfer function for the open loop, right?
Sure.
And then after that, okay, we got to develop the closed loop transfer function. And then maybe and then after that, we developed the closed loop transfer function in MATLAB. Okay, now let's go into our design editor, which I can show you guys how to use. And it makes life really easy. So then we're going to develop PID control. And then maybe we come back and we start looking at other controls. We start looking at Z transforms. We start looking into some discrete time stuff. Because like Dinsmore was ultimately supposed to be like a controls senior project. And that way, if we spend next semester focusing on controls and this semester knocking stuff down, I like the idea of that. Because then like maybe in a future project, then what they're going to do is maybe they're going to do a physical model of this thing, you know, and maybe make a little rig with 2 carts, you know, like set up on pulley systems, and they'll be able to vibrate along their little tracks or whatever, and you'll see the control system like maybe doing its thing, even if it doesn't have a package on it, you know, or maybe it will have a package, like a little printed box or something, you know, like, so that way you could start getting data on how it actually reacts and start getting your feedback loop to do its thing. And like,
Yeah. I see.
so like,
I
like
agree with you. I don't
it
see
has
anything wrong
scope.
with that.
I think like we do know what we're doing in a sense. We just need to figure out like more a direction, and like maybe that's clouding our vision as to how much we actually have done. So I think maybe next time we meet up, instead of looking at, which maybe should be tomorrow or Thursday, and really just bust this shit out, and then really start
Well,
kind
if
of
you guys
looking at-
want, feel free to add to the statement of work by all means, and like we
Yeah,
can-
yeah. I'm
I was
gonna
gonna say, I was gonna plan on it actually. I was gonna do that.
yeah,
Yeah,
definitely.
no, like
If
guys,
we-
add on it, and like we don't even have to meet. I feel like it's just a matter of like making sure we're all on the same page. Like, oh,
Definitely.
we either want the item to be delivered window to window or overhead.
100.
Yeah.
Yeah. Okay.
So I think in our statement of work,
Like we don't have to get too specific yet.
yeah, I think in our statement of work, maybe we should at first clarify our goals, right? And then we'll kind of just briefly talk about maybe 3 or 4 things in our statement of work. Like we'll talk about our goals. We'll talk about what we're actually gonna control, right? Because that's important. We're gonna because we set up our parameters for our mechanical system. We talk about maybe some feasible designs or some design constraints, right? So the highway and all
Yeah.
that stuff. And then we
Yeah.
talk about the types of controls we're going to need to create. So disturbance response for, X, Y, and Z types of disturbances, and some discrete time response. And basically it's part of it. This is really just the design, analysis, and control of like mobile delivery. That's
Yeah.
what the project is called,
Pretty
basically.
much, yeah.
So basically,
Design the model, run an analysis on it, make sure your shit doesn't break, and then
yeah,
electrically control everything, and then bam. we're
exactly.
ready to
So
go.
it kind of breaks itself down into 3 steps,
Yeah.
which is kind of nice.
It's just statement of work that's just being a bitch right now.
Yeah, I think
Big
it's just
deal. We just haven't dove into it yet.
yeah. I think what it is too is that we're looking at the big picture right now, which makes sense because we're going to go big picture.
Yeah.
Then we're going to slowly start narrowing it down with our statement of work, which is kind of what we're getting to right now. And then we'll kind of, all narrow down and do our work and communicate and figure things out together. And then later on, we'll start bringing it back out, and we'll be like, okay, well, like we did what we did,
Yeah.
and like, where does it go from here maybe? And then that's coming full circle, right? And
Wait, Thomas, you play Melee?
Yeah, dude. Why?
Holy crap, bro. I just saw Dolphin and I'm like tripping off it, man. Like I love Melee so much, dude. I haven't played like in a while, but yeah, dude, I love it. Why, you have what's your tag? You're Margasm or Gator?
I'm Gator, but I go by Tom.
I've heard of Margasm, bro. I've seen him stream a lot actually. Oh, is that even bigger bulk or just run one of the bulks?
This is that balcony, but this is completely off topic.
Oh my
what is
gosh,
this?
dude.
That's a 2D fighting game or what?
Yeah, this is
Yeah,
Super
2D
Smash Brothers Melee.
platform fighting game.
Yo, it's just like Super Smash, but like,
No, this is Super
Oh, it
Smash
is.
Bros.
oh,
This
it's
is-
just like,
This is faster Super Smash Bros. No, you missed your ledge dash there. God damn it.
what do you mean? It's like
It was my
fast?
first time playing on stream. I was nervous.
Oh, I bet, bro. This is back in 2017. That's sick, dude. I like literally right before I got to Cal Poly Pomona, because I became a first year at fall 2017. I literally got right into Melee around like summer of 2017. That box is so good. Bro, yeah, dude, like I fucking love Melee, bro. That game has definitely got me through a lot. It's so much fun.
Yeah.
I did
Anyway.
not know you had Dolphin. Sorry, that was just completely off topic. I'm sorry.
Yeah. We should play sometime.
I'm down, dude. Yeah.
But yeah. So what I also wanted to say real quick is that it is past 10 o'clock, and I don't
True.
really want to go too far past 10 o'clock.
Yeah, no, you're cool. I got.
And we already have about an hour recorded, and I don't want to make it a whole. 3
Oh yeah. You're right.
It's all good. I'm cool to end it.
Yeah, I'm cool with
Because,
ending it here, guys.
I think
Okay.
we
Just-
should all
just feel
just start
free-
working on the
I
statement.
want to see what you guys' idea is on the statement of work or something like that, or if you guys could add stuff throughout the week. And if not, we could always like meet up again. Like
Yeah.
Thursday,
Well,
right
I think
before
we
the
haven't
statement
really
of
worked on the
work.
statement of work, really, because
You have Eloy, but
well, yeah, but like
Yeah, I would
we
like
did
to,
it
like-
before. We did it before, so I feel like we have a lot more clarity as to now. I feel like it shouldn't actually be that hard to get a page out.
Yeah.
Yeah.
And you guys could definitely like do it too. Like I can see
Yeah,
you guys
definitely.
like having valuable ideas. 'Cause you guys have valuable ideas.
I would say maybe what we should do
Let's
Um,
continue
before
watching the
we-
VOD.
before we
No! It's so
Before we-
hard to hit ledge dashes when it's laggy as shit.
anyway, what were you saying, Daniel?
that before we like actually write something formally, just so our writing styles and like sentence structure doesn't conflict too much, maybe we should get like a general outline going of what we're going to write in our statement of work.
Oh,
like,
nice
one-
shine.
One
That was
page is
clean.
like maybe a
clean.
couple bullet points, so maybe like together before we start physically writing actual things, we can kind of write little blurbs and comment on each other's little blurbs and then kind of go from there.
Yeah,
Just because I don't know about you, I'm not like
we could.
best.
Yeah, we could totally do this on the statement of work page, and we could have a statement of work page on Discord that might also help.
exactly where people put you could put the little blurbs and then later on they'll make their way into the actual statement of work.
Yeah.
Little blurbs, like little ideas.
Yeah, like little
Okay,
things
yeah.
that like actually like impact our project, like because the thing is like we talk, but you know, outside of these discussions, I feel like we probably have a lot of ideas that don't get mentioned, you know?
God, Randall's so
Mm.
annoying.
Yeah, but I think we're pretty well on the same page now, and I'm really glad we got this meeting in.
Yeah, I felt like this meeting kind of added some clarity that it really doesn't matter how we do things because like it's all just gonna work out the same more or less anyway.
No, exactly. Like, if
Mhm.
anything, we just need to hammer, like, what we want to generally accomplish, like you said, our goals and the problem statement of work. And like you said, like, we'd
moving
always
shit from
just
A to
on
B when A to
mechanical
B
model.
is moving. That's literally our problem statement, more or less, you know. And then we gotta start talking about all the problems that come with that problem. But
Yeah.
fuck, it's 10 o'clock.
Oh,
I haven't
chillin', dude. The boy, bro. The
I
boy
haven't eaten
chillin'.
dinner, so I gotta go eat dinner. All I've eaten today was oatmeal for breakfast. So.
You're fucking lying, dude. That's
I understand.
tragic.
You can get out of here
Oh.
whenever you'd like, dog.
Yeah, no,
All right.
yesterday was the same shit. Yesterday I didn't have my first real meal until 8 o'clock at night.
Oh God.
Terrible, bro. I feel bad for you.
I'm just like sitting here at this fucking desk working and I get lost. So lost
Dude,
in-
I don't know.
lost in
Sometimes
the
I need to
engineering
eat.
sauce.
I get you, man.
It's like
I've
hop
just
on
been-
Bailey right now. No.
I've been sipping coffee like a fiend. That's what I've been doing. I've
Oh,
had,
gotcha.
I had-
I've been
I had
sipping
3
beer like a
cups.
fiend.
I had 3 cups today and like 2 yesterday.
Yeah.
But let me get going. I'm gonna relax a little bit and maybe try and do some more SolidWorks
Have a good night, man.
stuff. I don't know.
Yeah.
Okay. Later.
Love you, babe.
I gotta drop FEA, by the way. Because like
Chill.
I haven't learned shit in FEA in those past 5 weeks, and like we have a exam on Thursday, but like I don't know.
Fuck. Who's your professor?
Fuck, what's his name? Why am I blanking? Now I keep thinking of Maksudi, but his name is something different. Rapuli. I have Rapuli